Talking Industry, topical debate from the worlds of automation, manufacturing and engineering. Brought to you by DFA Manufacturing Media.
Topic today is automation and, well, let's get it right, robotics and advanced automation, in fact. We've got three fine panellists. We should have had four, but unfortunately Asif Mogul from Autodesk was unable to be with us because of two red lines on a lateral flow test yesterday. So we wish him all the best, and we will make sure that everybody that attends gets a paper from him to cover the materials that he would have presented, which would have been all about automation right across the value chain, not just in the sort of narrower manufacturing and processing area. I'd like to start quickly by just telling you a little bit about Talking Industry for those that haven't seen our online version. We started this during lockdown as an extra method of communicating with our readership and our audiences, and we've so far run 10. It's been very successful, and we run them through the medium of Zoom, and the idea is that it's a panel discussion rather than a conventional webinar. So we encourage the audience to participate throughout, ask their questions at any time, and we'll try to give you answers and so on to any questions that you ask. So we're hoping for an interactive flow through the session, which will last about 45 minutes. The online version, we've had something like 490 on our best attended one and 60 on the least attended, but they have been very successful, and the number of questions has been generally very high. So we do want you to ask your questions, put your hands up. We might even do a poll or two to find out your particular position on industrial automation as well, just to help with the interactivity. Don't be afraid to shout out, put your hands up. That's what we want you to do. So what I'm going to do is introduce the panelists in reverse order, finishing with the guy who will start. So at the end we have Volley, whose name I can never pronounce, so I'll leave that to him. Yeah, I'm fine with that. Yeah, he won't be doing it yet. So he's going to talk about collaborative robots in a case study, quite an exciting little 20-second video as well, which is well worth watching. And then his experience on working with innovative case studies and some of the process risks and how you address them. Before that, we'll have Nikesh, who's from Gambika, and he'll be presenting his experiences of working with a lot of SMEs in the electrical and instrumentation area, and giving us some statistics about how well the SME community is taking up automation, which, as I think we all know, in the UK is not necessarily as fast as we would all like it to be. So we'll listen to Nikesh on that one, and then first and by no means least, we'll have Mike Wilson, who will set the scene, tell us about some of the solutions that companies can adopt in order to accelerate their move towards automation. So with that, I will hand over to Mike, and he'll give us a kind of 5-minute presentation, and then we'll take some questions as we go rather than all at the end. Over to you, Mike.
Thanks, Andy. Good morning, everybody. My name's Mike Wilson. I'm Chief Automation Officer at the Manufacturing Technology Centre. We're part of the High Value Manufacturing Catapult, one of the 7 centres. We're a not-for-profit organisation that was set up to help UK manufacturing adopt technologies. And what we're really about is to provide a link between the developments that take place in universities, to take take those developments through the technology readiness levels so that they can be applied successfully within manufacturing. But also as part of that, we're also helping businesses adopt technologies, things that have already been proven and are commercially available. And we're able to provide the benefit of our expertise to help businesses, particularly small businesses that don't necessarily understand everything they need to know to successfully procure equipment, to actually adopt these technologies and implement them and operate them successfully. So maybe just to set the scene, and I'm not going to bore you with lots of statistics, but the International Federation of Robotics measures something called robot density. It's the number of robots per 10,000 workers. So it gives us a relative measure of how each country is in terms of adopting automation. And the UK is currently 24th on that table, and we're significantly below most of our major competitors. And you probably kind of say, well, that's not too much of a surprise, because in Asia they've got a very strong electronics sector and they're using lots of robots within that. Countries that have got very strong automotive sectors are also using lots of robots. Obviously we don't have necessarily a very strong electronics sector, but we do have car plants in this country. But one thing I should stress is you've got countries like Denmark, which are significantly ahead of us in terms of the adoption of automation. And Denmark doesn't have electronics and it doesn't have automotive. It's applying robots throughout general industry and particularly in food, and they're doing it very successfully and ensuring that all of their businesses are competitive going forward. And I think we're starting to see in the UK a change, if you like. We're starting to see an awful lot more interest in the use of robotics and automation. Some of that has come about from the challenges as a result of Brexit. Some of it has come about as a result of COVID. And we're actually seeing significant labour shortages today throughout all of our manufacturing sectors, but in particular in food manufacturing. And as a result, they're now starting to look at using a lot more automation and robotics. And this is not to replace people. This is to perform the mundane, the arduous, the dirty jobs, the kind of jobs that people really shouldn't be doing in today's manufacturing environment, and where we can now then redeploy the people where their skills are going to add value to the product. And to me, that's the most important point about all this, is making sure we use our most valuable asset, our people, as effectively and as productively as possible, and we use the robots and automation to perform those mundane, repetitive tasks. And that's really what it's all about. And in terms of the Manufacturing Technology Centre, that's what we're here to help people with, is to identify what the best opportunities are, to help them understand how to specify the equipment, to help them identify the most appropriate suppliers so that they can then procure successful solutions. And we're there to help businesses that don't necessarily understand how to do that. But it's all an education process. We're there to help, we're there to educate, so that we help the first time, the second time, the third time, the clients are doing much more of it themselves, so they become informed customers. They don't need to rely on our support going forward. So hopefully that's given you a little bit of scene setting, Andy, and I'd now like to pass back to you. Thank you
very much. Why do our SMEs need education when the Danish ones don't? What's the difference?
I think it's in the main lack of experience, because if you've not done automation before, it's very easy to fall into traps, it's very easy to make mistakes. And that's really what it's all about, is just helping those companies that have never done it before to see some of those mistakes up front and ensure that they don't fall into those traps. Some of us, like me, I've been around a long time, we made an awful lot of mistakes in our time and we've learned from those mistakes. So let's help people understand how to avoid them. And one of the key things for me is, firstly, it's about picking the most appropriate application. What a lot of end users try and do is pick their most challenging problem in the factory and say, let's automate that. But it is the most challenging, often because it's the most difficult, and that makes it difficult to automate. So it becomes more of a risk. What we would advocate is find something simple. Find a simple application as the first one to start with, and cut your teeth on that. Go up the learning curve on that very simple application, and then having successfully done it, then move on to the more complicated things later. And it's just about trying to express those kind of ideas to particularly the SMEs so that they understand that message, and then they take the journey, as it were, the most with the least risk, and ensure the most success.
So start small, scale fast is the message. Does that resonate with the people in the audience? Would you like to maybe comment? You're nodding, which probably means you're going to get a chance to speak. Do you mind? I think I'm clean.
So we come from the selling and the supply of robots, collaborative robots. I completely agree with what you say, basically, that it really is starting very, very simple, the easier tasks, and then working through and really getting to know the robots or the collaborative robots and how they work. Very, very easy, providing you start at that sort of easy position and work up. The nice thing about them is with all the end-of-arm tooling that's integrated with them, it really becomes like a plug and play for as you continue to evolve that sort of process of working with them. Yeah.
I sit next to you, that would make life a lot easier. Yeah. Food processing was mentioned as a possible market sector. What's your experience in the different sectors that you're working in?
Covering most sectors, but probably one of the biggest, and also where the biggest opportunities to improve processes and cut down on costs and improve reliability is definitely within the food industry, especially with the collaborative robots, because you are tending to package or to process lighter products. Where collaborative robots really struggle is anything over around about 20 kilos. So under that, boxes of crisps, nuts, fish, things like that, they work really, really well with. And of course, most of them are IP65, so they're washed down. They can work in those hostile environments.
Fabulous. Well, we'll get a chance to talk a bit more about collaborative robots later on, so you two can probably have a really sort of fruitful discussion at that time. Thank you. Anybody else want to comment at this stage? Anybody? Yes? Marvellous. Thank you.
Morning. Adam Hall, Malvern Analytical. We make industrial instrumentation, characterization instrumentation. One of the things we found was COVID, obviously. People wanted to automate labs. That was the thing that they were really keen on. The question to MTC really is, those sort of lab environments are very much out of universities. It's Python scripts, it's open source code, it's all ingenious but quite bespoke. When we try and go into companies with an industrial solution, and they go, we can't afford that, that's just too much. How do you put the value on an industrial solution opposed to a something you've got working with a Raspberry Pi? How do you make that step?
I think an awful lot of that is about ease of use, reliability, and meeting certain standards of performance, if you like, because an industrial solution has to achieve those kind of standards, whereas if an organisation builds their own solution, then that's fine. You know, I'm not saying there's always a right way or a wrong way, but if you're particularly in labs, you've got to address things like traceability. You've got to ensure that you've got reliable performance, and it's difficult to quantify that necessarily in terms of pound notes, but it is worth something. And I think that's, if you like, the trick is to try and figure out what is that worth and how can you put a value on it. I think the other thing that's important, which is often true of industrial type solutions, because you've got the reliability, they can operate more consistently over longer periods of time, potentially 24 hours a day with nobody in the facility. So you can get more out of what you've put into that facility. So people will always try, if you like, to do things cheaper, but there's often false savings associated with that. And one of the keys to all of these is actually developing the business case up front, the return on investment, so to actually make sure that you quantify all of the benefits that you're going to get, so you then justify the right amount of money to buy what it is you really ought to buy, rather than trying to do it on the cheap. I know that's not a sort of black and white answer, but I don't think there is a black and white answer to that question.
Nikesh, do you want to come in on that? Because making the business case is a very important aspect of all this, and I'm sure all of our panelists would like to chip in.
Yes, yeah, definitely. Actually, it's a very interesting point you make. And I'm from Gambika, so we're the trade association for industrial automation, process control, lab tech, and test and measurement in the UK. And it's very interesting that you mention the gap between what universities are asking for and what industry are doing. Because at the moment we've just started our very own university engagement sector at Gambika, and the idea of that is to try and bridge that gap between industry and universities. And we held an event online. We wanted to do it in person, but obviously you couldn't. And what came out of that was quite a lot of tangible action points for us, where industry sort of said, universities don't know, they're not preparing our future workforce for us. And equally, universities said exactly the same thing. They said, well, industry are not prepared for our graduates. So it was this gap between the two. And obviously we can't directly influence the curriculum. It's not something anybody can do that easily. But we started to work on trying to build groups and build collaboration networks, build events where we do discuss, before students are released from university, you sort of say, these are the sort of things that we would like to see in final before they're actually, at that point. So it does have its benefits, and what we're seeing is a great improvement in those relationships between universities and industry. So yeah, when you say the importance of trying to bridge that gap, it's very important. And then, as Mike mentioned about building the business case, on the business side of things, yes, before any company, any of our SME members want to automate, they look at the business problem first. That's the starting point before starting their journey. They have to understand what return they're actually going to get before they actually make an investment. And at the moment, it's so difficult to see how can you see a return on investment of data. It's not physical like a big piece of machinery. It's something that's on your computer. It's something that's stored in a cloud even, and it's very hard to see that return on investment. So building that case is only the best way we see it is when we have discussions amongst the members. When you speak to a similar business like yourself and you say, what are you doing? And then, if somebody's got a case study where they can say, I invested in, this bit of cloud or this cloud edge or a digital twin that helped me here, then they can turn around and say, okay, that's my return on investment has been this, and another company can look at them and say, okay, that makes me want to invest. Without those discussions, it's very difficult to build that business case. So I think, that collaborative discussion is very key.
You often find that you get best results in benchmarking if you talk to people in different sectors, because they don't feel that they're competing with you, and they'll often share information, help you with techniques that maybe somebody in the same sector wouldn't be so comfortable with. So that's always worth looking at.
Definitely.
The question about universities, I wonder whether that's ever been any different. I started life as a metallurgist, and bashing pieces of metal, but if you go back to my old university department now, everything's on the molecular level. I don't recognise anything that they're doing, and what's changed is the speed of innovation, and I think that's what's made it difficult for universities. But on the other hand, I think there's better collaboration between industry and university than there used to be. So there's balancing factors on both sides, I guess. It's like any new technology always struggles with standards for the same reason. It's moving so fast that standards and education struggle to keep up.
That's it. And there is, as you say, there's no standard protocol for what should be done after university, what should they learn. Each university has a different method of teaching, let alone each company, each corporation has a different want from their graduates. So there's no standard for that. So it's about developing similarities and finding areas where you can be like, okay, this is an interchangeable skill. It's something that those are the things that you look for. And it's about creating that in the university space, in the industry space, so that they can work together much easier. And it's so important. It's something that we should all be doing. Trying to focus on that future workforce, definitely.
Folly, do you have anything to add on? Because you've been in kind of a startup type of situation, making the business case for using automation.
Ladies and gentlemen,
They just don't want you to speak. Hang on.
in its time is the opening presentation by the High Value Manufacturing Capital.
Okay, we...
Sorry.
Perfect.
The business case is one thing, but I would like to say it's not always... I mean, the question we would always ask is, what does the solution need? More than trying to push a certain solution into a certain industry or the university, for that matter. So the real question would be, does that solution actually need industrial components? Having a Raspberry Pi is perfectly fine. If it does the job, why not? So our focus always is to look at the solution, what it needs, rather than saying industrial components are the way to go, and we need to try and push them into certain directions. It always would depend on what the environment is. For example, if it's the food industry, definitely we need to aim for IP65 when it comes to the component certification. But when it comes to a lab environment, maybe you don't need the IP65 component. Your requirements are very different. So, of course, having a Raspberry Pi or using a Python API to interface into your cloud would be actually the right thing to do. So it would really depend on case study to case study, and naturally when we talk about the one I'm going to talk about today, we'll also try and tell you that we had a mixed bag. In some areas we used industrial components, in some areas we didn't. We used industrial PCs. So it depends. And in terms of the business case, I think every company looks at it very differently. Some companies are very forward-looking. Like one of our first projects when we started was with a printing company, and they deployed the first collaborative robot in the UK within the print industry. They were not being used before, but they were very forward-looking, and they took the risk even during the time of COVID. But then you'd have different companies, even the multinationals, they stopped spending money during COVID completely. So you also have obviously a mixed bag, but we always try and take the approach Mike suggested earlier, which is start with the easy use cases, start simple. When we go out to clients, we don't try and push a certain solution. We don't try and push a certain direction with them. We just try and find the easiest problem they have, and it may be just giving them a robot to play with, and that may solve their problem, and that's perfectly fine. We don't need to give them a solution. So it really depends on situation to situation. But we always take the approach that the first thing to do in the UK right now for industry is to address the risks they have in their heads. Companies are usually concerned with collaborative robots or automation in general. What's it going to do? They want to be really sure that their money's going to give them the payback. And the best way to address it is to just approach the easiest applications first before you try and go more complex.
That's good advice. What advice do you give, Mike, on how to calculate payback and what's a good result?
I think one of the key elements of that is to make sure that you're actually trying to capture all of the potential benefits or savings that will come from the application of the automation. What an awful lot of businesses typically try and do is they look at how many people they're potentially displacing, and they look at the savings from that, and they look at the cost, and that's about as far as it goes. But there are lots of other potential benefits, which might be things like reduction in scrap rates, it might be greater productivity, it might be reduction in labour turnover. So there are lots of potential savings that can potentially be brought into that equation. And if you do that, then you will potentially then justify a larger sum of money that then allows you to maybe buy something slightly different or buy a more complete solution. I think the other element that's important is, for my mind at least, I understand businesses have a requirement to achieve a return on investment. It may be a payback of 1 year or 2 years, but the thing I would always stress is that the equipment's going to last a long time, that there are robots and automation systems that are running very, very successfully that have been installed for 10 years. There are some in this country that were installed 20 plus years ago that are still running very successfully. So when you're looking at very short return on investments, it isn't necessarily the right answer. You do need to be thinking longer term, and an awful lot of our competitors overseas are thinking much longer than 1 year or 2 years, and if people did that, then they probably start to justify greater levels of investment. And to me, it's really about ensuring that our businesses are highly productive, highly competitive, to make sure that they're successful going forward. And it's not a simple let's justify spending £100,000 over a 1 year payback. This is much bigger than that. And I think we need more business leaders, if you like, willing to take that step, as it were, to have the vision of where they want to be in 5 years' time and figuring out what that plan might be, what that looks like, and then investing in that development.
Thank you. I think there's some very important points there. And just to highlight your point about digitalisation, you know, that Asif would have talked about a much wider range of benefits, right the way from designing a component to dispatch. And once you start to digitalize or automate one section of what you're doing, then of course additional savings do follow from that in other parts of the business. So that all helps with the payback. And there was a point made on training recently, and just to say, in a plug, that we have another Talking Industry Live at 1 o'clock, where we'll be talking about the whole process of education right the way through from primary school to apprenticeships, with 3 speakers explaining how that process can work and train engineers in the right way, really from a very early age. And I think that's absolutely critical in this country with so many people retiring. You know, frankly, I mean, our demographic is leaving a huge skills gap in the middle, so we need to address that. So that brings me back to Nikesh. Now, I've no idea how much of your presentation in this unscripted form you've already given, probably quite a lot of it, but maybe picking up your point, or Mike's point, about the 1 to 2 year payback and what your experiences would be there.
Yeah, actually, it's funny you mentioned that. I've got a few points from my actual presentation written in stats in my head, but they're not quite in my head. They might be on the paper. But yeah, so there's a few things that Mike mentioned there with the return on investment factor and the having patience. I think that's key to it. You know, it's not. You might not look at the return tomorrow. It might be a 2 to 3 year investment at least you want to be looking for. And then what I would say is it depends on what the return is for you. You know, it's not necessarily monetary. That's something that needs to be stressed quite a lot, actually. It doesn't have to be a profit increase. You know, maybe that is a business goal. Obviously, every business goal is to increase profit, but there's other things that you can get from automating. You know, you can get your sustainability. You can, at the moment, you know, becoming carbon neutral and net zero is very, very important for many businesses. So end users will find that, you know, the reason for automating is because they want to better their carbon footprint. And there's many technologies here today that will actually help you do that. You know, a lot of, you know, from many of the equipments that our members manufacture actually help your process be more sustainable. So that's one area of investment that you might look at. Another thing is time. Mike touched on it briefly, but time is invaluable. You know, you can't put a monetary value on the time of your employees. And if you're automating certain processes, those mundane tasks, those monotonous, repetitive tasks that people don't want to do, you're freeing up valuable human time of your employees. And that time is priceless. So I find, you know, when discussing with a lot of SMEs, when they're saying, oh, we've decided to automate that process, now our employees have so much more time on their hands, they can do this, this, and this, and they've given them even more jobs to do. And that's, you know, that's improving your employee satisfaction in itself, because they don't have to do tasks they didn't want to do before that a robot could do. So personally, you know, I think there's so many returns on investment from automating, not just monetary, not just, you know, one track, and again, not just overnight. You know, it might be 6-month return, it might be a 2 to 3 year return, it might be 5 years. One thing that the pandemic has done is it's acted as a catalyst for automation. You know, people have had to start doing remote machine maintenance that they didn't need to do before, or they did do before, they just didn't have to do it every day. Whereas now you find it's becoming the normal thing to do, and they're doing it more often, and what they would have perhaps done in 5 years, they've done in 5 months. They've developed that sort of technology because they've had no choice. So really, I think, you know, lots and lots of benefits have come out of these situations for our industry. And one of the statistical things I can say is that we've seen huge growth in our members. You know, I can't talk in any specifics because it's crossing boundaries, but I can say that as a whole, as the industry as a whole, it's in a positive direction, and we've seen great growth from, you know, from a point of view from the sales and orders, things like that. It's really, really up, and they're all automation companies. You know, all our members are automation companies, and that's just a way of saying that, you know, automation has been, you know, the answer to the pandemic in a way. You know, companies have needed to automate faster than ever before, and we're seeing real positivity in that section.
From the point of view of the workforce, what do they need to do to transition from work to working with robots, and how do they get there?
Oh, that's a good question. I don't know if probably Volley might be able to answer a bit better than myself in terms of robotics, but I think there's very little needs to be done on the human side of things, because of collaborative robots. You know, I think the safety aspect is being developed into them. So, you know, obviously health and safety of employees is important, but I think humans need to understand that the robots are not out there to steal the jobs. They're there to work alongside you. And you know, they can work together collaboratively. I heard the term Industry 5 thrown around very recently, which is jumping Industry 4, and that's all. And the only thing they've added to that is the collaborative environment between humans and robots, and that is literally the addition to it. So it's something where we're looking at seeing. You know, I don't know if Volley, you want to add to that in terms of what humans need to do.
They just need to try working next to robots, and once they try it, I think they will realize that it's possible. One of the first projects we actually worked with was with BMW Mini in Oxford, and we've currently got 3 projects running there, and they all have been fully collaborative. No additional safety devices at all. So it is possible. Obviously, you have to look at the risk assessment, you have to look at the risks, but it is possible for robots and humans to collaborate in the same workspace. There are plenty of case studies out there. I mean, even in this show right now, there's a lot of robot suppliers here selling collaborative robots, you know, including us. If you talk to any of them, they will all tell you the same thing, that it is possible for robots and humans to collaborate. I think the biggest barrier, if I was to say, is just in our heads, you know, it's in our minds, in people, you know, just the concern and the worry of what is it going to be like working around robots. So it is a cultural change. But in our experience, once you deploy a cobot into a certain company and people of that company start to work with the collaborator robot, the shift doesn't take more than an hour. It's just that initial step. Once you take that first step, then it does get more comfortable.
One of the things people might worry about, of course, is the safety, and how do you actually do a risk assessment? I mean, what are the practical steps in doing a risk assessment?
It's not really an easy answer. unfortunately. But it's very simply put, how likely is a certain, very simply put, you would start to look at what is the risk, what risk exists, and if a risk exists, how often is that risk actually going to occur? And if at all it occurs, what's the damages it's going to do? Obviously, it's quite a detailed method on how you do a risk assessment in a setting like that, particularly with collaborating robots. It's a very specific way to do it, obviously, but it's not overly complex. But it also doesn't need too much technical knowledge. It's just common sense of, what's the risk, how often is it going to happen, what's the damage if it does happen, how many people are exposed, etc., 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 etc.
So there's no kind of formal method. You just kind of
there is a method. So there is a method to do a risk assessment, but it's just not very easy to explain. And there are templates available out there. It's definitely not rocket science. I can promise you that. It's very, very easy. And there are templates out there.
Thank you. Do you get involved with that risk assessment side? I've wondered if you might. Yeah.
Yeah, we do on many occasions, and the really nice thing about the collaborative robots is that you can put sensors in place, cheap sensors, that if people are coming towards them, they slow down.
Correct.
And as they move away, they speed up. So this is one of the ways that we can do it. But also, it's about what could happen around it. So you have to do an assessment of the area, the working conditions, the amount of people in there at the time. But yeah, it's all part and parcel of providing that service, to making sure that the customer, when they get it, one, it's in a safe environment, it's working well, but also it's doing exactly what they want them to do.
Thank you very much. Right, I think it's time now for your little video, Volley. So I'll press the buttons if you like, and you can talk to it.
So perhaps just.
We have a dead mic again.
Hello. Hello. I just wanted to start with an introduction. So just as a quick introduction about myself, so I'm Volley and I'm the director of Vicaso. We're a new company, we're about 2 years old now, and we focus solely on collaborative robot solutions. So we'll share one of our case studies with you now, but my background is in manufacturing. So when we started the company, our focus was to drive automation towards the UK manufacturing industry. The timing was great. We started in February 2020, and March 2020, obviously we all know what happened. So I couldn't complain about the timing, but let's have a look at the video. So this is one of the first projects that we did, and the application was to swap batteries in service drones. So it's a completely outdoor application. It uses a collaborative robot with an artificial intelligence-based vision system to detect the position of the drone when it lands, then collects the battery from a battery bay, replaces the battery into the drone, and the drone takes off. So these are service drones. The company we worked with is called Mana, and they essentially are a drone, they're a logistics company, is what they call themselves, which basically means that they're using drones to pick and drop parcels outside people's houses. And by the EU, by the regulation, they need to swap the battery in a drone after every flight. So at the moment, or before we started this project, they had 5 people literally standing changing batteries in drones. Every time the drone lands, they have to change the battery. Every time the drone lands back, they have to change the battery again. And the idea was to automate this part of the process so that when they want to scale up their activities, which is they want to move from one town in Ireland excuse me, to multiple towns in England and eventually the whole of UK, the idea would be that they could deploy a system like this and they would not need to have 5 people standing outside in rain in all weather conditions, just swapping out batteries. So this is what we started with. And the reason I wanted to highlight this video predominantly was to show you an example of what is actually possible with automation. In this particular setting, we're not using the collaborative robot for the sake of working next to people, as you saw. But the benefits of collaborative robots is not just about working next to people. It's about the ease of programming, it's about the ease of integration, and it's about making the whole application low cost. Now, if you imagine this is one application, which let's say costs between 90 to 100K. Now, the moment you assume that number to be 150k, and if you have to deploy 200 of these applications, that 50k offset makes a huge difference. So our decision of using a collaborator robot in this case was to make the whole application cheaper, remembering that we have to scale it up. Now, naturally, because this was an outdoor application, so we had to use industrial components. So we've used the Siemens PLC, we've used the Siemens HMI, we had a linear drive, so we've used all of those off-the-shelf industrial components. But by the sheer nature of the project, we had to have our system communicate with their servers wirelessly. And the AI-based vision system also uses a standard industrial PC. Because it needs very high computing power, so our off-the-shelf Siemens IPC just doesn't work. So we focused on that application, looking at what is actually required, more than thinking what do we have already and how can we use it. And the second point I wanted to make also was the approach to risk. Naturally, is when you look at an application like this, the first thing that pops to your head is how would it be possible? How could you do it? It's not been done before. So where do you start? You compare this to a very simple pick-and-place application into a food company. The risks are tenfolds greater here as opposed to a pick-and-place application in a food company. So the key reason we wanted to share this video with you was to demonstrate that an application like this can be achieved in 4 months, whereas a pick-and-place application could be achieved in a few days. So the idea is that we'd like to try and motivate industries, multiple industries, manufacturing being the biggest one, that applications today are possible outside the manufacturing world. They're going into places you've not thought of. So if the manufacturing industry in the UK doesn't scale up now, it just might be too late. And this case study proves that if a case study like this is possible, I think most use cases in the manufacturing industry are possible. The key here is to aim for low cost, and the key here is to aim for speed and low cost, because this is what will motivate companies to accept more automation. And we're here also at the show, obviously this panel also with the same agenda. We want to try and push more automation. Not look at what we have and say this is what you need. It's just looking at what do you need and how do we get that to you tomorrow. It's the speed and the low cost is what we're trying to aim for.
I mean, that's more than just substitution, isn't it, of human labour? That's taking it a stage further on into applications which actually might not be feasible, and certainly in any sort of volume scale wouldn't be feasible. So you're looking at really brand new sectors. How do you identify them? I guess you come to shows like this and meet people.
So new sectors like this, we actually surprisingly they find us more before we find them. It was an eye-opener. We didn't even know this industry existed or an opportunity like this would exist. But it was them. They came up with the idea that they wanted to automate that process, and they wanted to use a collaborator robot for it. So they had done the homework, and they came to us and said, "Can you guys do this?" Initially, we went, "We don't know. We're going to have to think about it." But naturally, the position we were in at the time and the position they were in at the time, we both basically decided to take the risk collectively and go for it. But it is hard. It is hard to try and step into cases like this unless and until the user themselves is motivated enough. Like this was not, we didn't motivate them. They were self-motivated. We just gave them a helping hand.
Any comments or questions on that? Because I think that's a really exciting application of what collaborative robots can do. Yeah?
Just back to the collaborative robots again. So, you mentioned that there's things you can do, sensors, that sort of thing. That safety integrity that you build into it. Can you just go a little bit about why a co-robot has a inherent safety in it rather than a standard robot where you need to put guards around it? Why is it inherently safer?
So no robot in the world is inherently safe. None of them. No, even collaborator robots. Inherently safe designs with robots don't exist yet. But what it means is the collaborator robot has inbuilt force and torque sensors, the safety functions of which are safety rated to the same level as an industrial robot. The biggest difference is with an industrial robot, it doesn't have the force sensing. So the only way to bring the robot to a complete stop is by using an external sensor. That's with the industrial robot. With the collaborative robot, you don't necessarily need an external sensor. Just the sheer force feedback of the robot itself gets it to stop at the same safety level as your industrial robot. But the only thing I'd like to say is the robot itself, out of the box, is not inherently safe. A design like that doesn't exist because it depends on what you mount at the end of the robot. The robot is just your hand, right? It's just replacing your human hand. But it depends on what you're doing with it, how fast you're doing with it. If you get the robot to carry a knife, then by no means it could be inherently safe. So it would depend. But having said that, a lot of end effectors that you could use, a lot of applications for pick and place that you could use, you can make them inherently safe. Like palletizing is a very common use case in warehouses and food industry. We can make them inherently safe. There are solutions out there that use additional safety, but they don't necessarily need to be used.
So that's where your risk assessment comes in, because you've obviously got to balance off how safe your robot is. Correct. Into that risk assessment.
Correct.
Yeah.
And what would happen if something were to happen? How big is the risk? Is it going to break your head into two pieces, or is it just going to push you and you're going to take a step back?
Yeah.
Yeah.
And then that brings us back to the initial comment of the training and the awareness of people within the organisation that you need to think about safety and why is this robot safe and this one isn't, when they, on the face of it, look exactly the same.
If we were ever given the choice, if the customer asks us that this application needs to be automated, and if the choice is that application could be automated with a collaborative robot, and it could be automated with an industrial robot, we would always push for the collaborative robot. It's just because you're buying more for probably the same amount of money. You're buying something easier to work with. You're buying something more sensitive for probably the same amount of money. So we would always push the direction towards collaborative robot because it just has the benefits associated with it. They're lightweight to carry, so naturally they have a lot of benefits over industrial robots. But yeah.
Are there some limitations on what loads that collaborative robots can?
The payloads are going up. At the moment, I would say you would probably look at a 20 kilo mark for use on a collaborative robot. It still doesn't mean you can use it in a fully collaborative fashion, because what if the 20 kilo drops on your foot? Yeah. It has to be assessed. But I think that payload capacities are going up. But it's also a case of, does the application need to be fully collaborative? Maybe not. So at the moment, the way we see the marketplace, there aren't really as many use cases for payloads bigger than 20 kilos. I think 10 kilos would probably be the sweet spot for collaborative robots, 15 kilos, something like that. But naturally, the more weight you're carrying on the robot, the more inertia the robot's going to have. That means when it hits you, you're going to feel a higher force. So usually I would say at the moment it's at 20 kilos.
Thank you. I like the term fully collaborative, or perhaps non-fully collaborative, which can you define what you mean by that?
So fully collaborative, the way we define it is that when you put a collaborative robot into use without any additional safety at all, no safety devices at all, no detection method at all, you could still have a collaborative setup by the means of using a safety scanner to slow the robot down if you're getting too close to it. Or you speed it up as soon as you step out of it. There are also capacitive skins available, which means that if you're getting in close proximity of just the robot tool, you slow down the robot or you speed it up again. So there are multiple different ways of achieving a safe application, yet collaborative application. Like the first project we did, I did at Mini when I was still working there, was a semi-collaborative application. There weren't people there all the time, but the benefit of having a semi-collaborative use case is that you need less footprint. So you're not using too much space on your factory floor. So the configuration we had there where the robots slowed down as soon as you approach the sensors, as soon as you walk out, they speed up again. But by definition for us, fully collaborative means no additional safety at all.
Yeah, it's very interesting. I think that there's probably a lot of potential in that mid-range that maybe isn't being exploited. Okay, we're coming close to the end of our session. So the takeaways that I've had, I think, have been about the business case, the relationships between collaborative and non-collaborative robots, Mike, do you want to just sum up from your perspective anything that we haven't covered yet?
I think I'd really just like to stress that for people that are doing this for the first time, is seek out some independent advice. And I know that that's potentially selling the MTC, but that's what we're there to do, because you probably heard that there's discussion about should it be collaborative, should it be industrial, and if you get the independent advice, they're going to point you in the right direction. What is the right answer for the particular application you're going to look at? Because it isn't completely black and white, and it isn't always one or it isn't always the other. It's about finding the right solution. So you know, please seek out advice for those that are new to this, because it could help you avoid an expensive mistake.
What percentage of the applications that you see are collaborative, and how many are non? And is that changing?
The number of collaborative robots is still relatively small in comparison with the number of industrial robots. It is changing because we're seeing growth, I believe, for collaborative, particularly in kind of general industry applications, particularly in SMEs, whereas the more industrial robots you typically see in the larger businesses, and you will see lots of them in automotive, for example. But again, I think that's a slow change, and I don't think we will see a step change. I don't think we'll see collaborative take over from industrial or vice versa. I think, in my head at least, they're really just two versions of the same thing. You know, collaborative robot is still effectively an industrial robot. It's just got different functionality, and I think that's a better way of approaching it, rather than trying to say they are different.
So, with your SME hat on, Nikesh, would you agree with that kind of approach?
I completely agree. Yep. It comes down to the right application. It purely becomes, what do you need it for, and go to those experts that will help you, and they will help. You know, companies in themselves have their own experts, but there's also external experts who can, you know, give you that advice, help you avoiding that expensive mistake. You know, you've asked a lot of questions today about the differences with collaborative and industrial robots, and it shows that there's that further education about collaborative robots which could be provided. And you know, obviously within the SMEs, it is about training your workforce to be comfortable with them. You know, doing those extra trainings will allow them to, you know, be comfortable working alongside robots. I mean, we say the joke all the time where you can make your factory foolproof, but you can't make it idiot-proof. You know, you need to train them to not be, you know, idiots around this technology, because it is advancing, and, you know, it can be dangerous, but with the right training, you know, the right expertise, you can make sure that, you know, humans and robots can work absolutely, you know, fully collaboratively together. So, you know, there's that case for it. So really and truly, just make sure you're using the right robot for the right application, seeking that expertise, and you know, you'll find yourself in a much better position.
Thank you very much, and that's a good optimistic note, I guess, on which to finish. I'd particularly like to thank you for introducing me to Industry 5.0, so that's something I'm going to have to go away and look at, and Volley for the semi-collaborative robot. So that's on my learning curve. We'll draw it to an end then. If you want to continue with any discussions, our panelists will be available both by email contact and also through our LinkedIn Talking Industry pages. So if any questions come to you that you want to discuss afterwards, then please do so. We have another Talking Industry at 11:30, which is on maintenance 4.0, 4.0, not 5.0, and that's the value of asset management. So with that, I'd like to thank our three speakers for a great contribution. Thank you.
Thank you. Thanks, Andy.